lot of calculus is about understanding the qualitative features of functions. Nobody really cares about f of 17, but you might care about f of a big number qualitatively. We're going to try to make this concept of big number a bit more precise. Well, here's how we're going to get around talking about a big number. We're going to talk about the limit. To say the limit of f of x as x approaches infinity equals L means that f of x is as close as you want it to be to L, provided x is large enough. So instead of talking about just plugging in a big number, I'm going to say f at some big number, so to speak, is equal to L if I can make the output of f close to L by plugging in big enough numbers. At this point, we've seen a bunch of different definitions of limits, but they're all united by a common theme. What if someone had asked us to cook up a definition of the limit of f of x equals infinity as x goes to infinity? Could we come up with a definition for this? Yeah, absolutely we can. Here we go. The limit of f of x as x approaches infinity equals infinity means that I can make f of x as large as you want it to be, provided x is large enough. Consistently, when we're talking about infinity in limits, we're never actually talking about a specific value. We're just talking about a value which is as big as you want it to be. Let's go do an example at the blackboard. Here's a question. What's the limit of 2x over x plus 1 as x approaches infinity? Before we dive into this analytically, let's get some numerical evidence. So here's my function again. F of x equals 2x over x plus 1. I want to know qualitatively what happens when I plug in big numbers into this function. So let's say f of 100. Well, that's not too hard to figure out. 2 times 100 is 200, and 100 plus 1 is 101. Now 200 divided by 101 is pretty close to 2. And there's nothing too special about 100, right? If I'd done this for 1,000,000, I would have gotten 2,000,000 over 1,000,001, which would be even closer to 2. Numerically, it looks like this limit's 2, but we just figured that out by plugging in some big numbers. I want a more rigorous argument, some analytic argument that this limit is actually equal to 2. Now, how am I going to proceed? My first guess would be to use the limit law for quotients. This is the limit of a quotient, which is the quotient of limits, provided the limits exist and the limit of the denominator is non-zero. Bad news here is that the limits don't exist. The limit of the numerator is infinity, which isn't a number, so I can't use my limit law for quotients here. Instead, I'm going to sneak up on this limit problem by wearing a disguise. I'm going to multiply by a disguised version of 1. I'm going to multiply by 1 over x divided by 1 over x. Now this is just 1. Admittedly, I have changed the function. The function's not defined anymore at 0, but for large values of x, this doesn't affect anything. And I'm taking a limit as x goes to infinity, so I only care about agreement at large values of x. I'll do some algebra. This limit is now the limit of 2x times 1 over x, which is 2, divided by the limit of x plus 1 times 1 over x, which is 1 plus 1 over x. Maybe it doesn't look like I've made a lot of progress here, but this is a huge progress. The limit of the numerator is now a number, it's 2, and the limit of the denominator is also a number, and a non-zero number at that. So I can use my limit law for quotients. This is the limit of a quotient, which is the quotient of the limit. It's the limit of 2, the numerator, divided by the limit of the denominator as x approaches infinity. The limit of the numerator is just the limit of a constant, which is 2. The limit of the denominator is the limit of a sum, which is the sum of the limits provided the limits exist. And they do. The limit of 1 is just 1. And what's the limit of 1 over x as x approaches infinity? Well, that's asking what is 1 over x close to when x is very large. Well, I can make 1 over x as close to 0 as I like if I'm willing to make x large enough. So the limit of 1 over x as x approaches infinity is 0. That means my original limit is 2 over 1 plus 0, which is 2.